Hey class, today we're going to be looking at solving quadratic equations. We're going to look at just a few different ways to do that, mostly factoring, quadratic formula, and then using square roots. We'll also talk a little bit about the discriminant today. So let's get started. So quadratic formula, or quadratic equation anyways, is an equation in the form ax squared plus bx plus c equals 0. It can be in a different form, but really what we're looking for is that x squared in there being the highest degree of the polynomial. That's going to make it a quadratic equation. So the first thing we're going to go over is factoring. Since this is college algebra, I assume you've done factoring before, and hopefully this is just going to be a little bit of a review for you. I have more factoring videos on my channel, and there's a ton online. So if you need extra factoring help, please see if you can find some more videos or come see me for help. So a little bit of a review. I'm going to just do a couple of these here. One way to factor that I know my students really like doing is using what they call the box method. And what we do for the box method, now I do it a little differently. We put the first term in the upper left box and the last term in the lower right-hand box. But I know some people at this point multiply that A and the C value. I don't, for a lot of reasons. Without getting too far into it, this is how I would suggest you do it. Figure out what, and it's going to kind of be like a let's play with it until it works sort of situation, guess and check, I guess, educated guess and check. What two things multiply to 3x squared? Well, there's really only one option, 3x times x. And I'm not sure where the 3 is going to go yet, and actually it won't really matter for this problem. And then what times what is negative 2? Well, again, there's really only one option, 1 times 2. One of them has to be negative. But I'm not sure exactly where the 1 and the 2 are going to go. I know I want to end up with a 5 in the middle, so let's just try the 1 here and the 2 here, and we'll see what happens. I want one of them to be negative, so I usually wait to see which one's negative after I multiply. If I multiply this, I've got 2 times 3x is 6x, 1 times x is x, and if I make the 1 negative and the 2 positive, I end up with a positive 5x in the middle, which is exactly what I wanted. Now, I got lucky, and I put the 1 and the 2 in the right places the first time. If I had had those switched, it wouldn't have worked out, but I could just erase that and then try them in a different order. So that's kind of what I would suggest you do. Right, and then this is my answer. Always check to make sure that the inside of the box adds up properly to your equation, and make sure the outsides multiply to the insides properly, looking specifically at those negative signs especially. Right, so our factors are 3x minus 1 times x plus 2. Make sure you put your factors next to each other like I did, because they are being multiplied. I've seen some students stack one on top of the other, and that doesn't really make sense because that doesn't show the multiplication. All right, number 3 is slightly different. We only have 2 terms here. So we're going to have to go about this a little differently. We don't really want to put a 0 in our factoring box. That gets a little weird. So what we can do instead is think about GCF. So a greatest common factor, and we always kind of want to think about this. It didn't come up in the last problem, but always look at your terms and see, is there something that they all have in common that I can take out and simplify this for myself? In this case, 4 and negative 2 both have a factor of 2, and the x squared and the x both have a factor of x. So I can factor out a 2x. I'm left with a 2x minus 1. And oops, I forgot to read directions. Oh, that happens. It says solve using factoring. So actually, we need to go back to the other problem and finish it, and then we'll continue. Oh my goodness, this happens all the time. All right, so now that I have the factors, I'm going to erase my box really quick just so to give myself some more room. So I have my factors equal 0. We're going to use the 0 product property, which means anything times 0 is going to end up being 0. So either this one has to be 0 or this one has to be 0. So I can split them up and write them separately and then solve. If I add 1 to both sides and divide by 3, I get x equals 1/3. And if I subtract 2, I get x equals negative 2. All right, now that we've finished the problem, let's go back to our next one. I have my factors. I factored out that 2x, the greatest common factor. Now I'm going to use my zero product property. 2x equals 0 and 2x minus 1 equals 0. And then here I would just divide by 2. Well, 0 divided by 2 is still 0. So that's one of my answers. And adding my 1, 2x equals 1, dividing by 2, x equals 1/2. So there are my two answers. Sometimes we'll have two answers. Sometimes we'll have only one answer. We'll see an example like that. Sometimes we'll have imaginary answers, which we'll also look at. All right, so that's a little bit of factoring review for you. The next one is using square roots. So the difference between what we were looking at in the first group of examples and what we have here is the first group had x squareds and x's. In this group, we only have an x squared and then just numbers. So it's a little different and actually a little easier. In this case, all we have to do is isolate the x squared and then use square roots. So first, I'm going to move that 25 over. 9x squared equals negative 25. And again, if I am skipping examples, that means I want you to try it on your own and then check your answer with the filled in notes on our course calendar. And then divide by 9, I have x squared equals negative 25 divided by 9. We want to square root both sides, and this is super important. We have to remember a positive and a negative in front of that square root. So a little bit of a reason why, if I have x squared equals some number, and I use a square root to solve. So this is when we are creating the square root to solve for something squared. Then in this case, if we think 2 squared is 4, well, so is negative 2 squared. So I should have two answers, positive 2 and negative 2. And I'm not going to get that negative 2 unless I remember to do plus or minus. So here, when I square root both sides, I can't just say, oh, x is the square root of 4, which is 2. I have to have both a positive 2 and a negative 2 to get all the answers for that squared term. Same thing if it looks a little more complicated, like negative 25 over 9, we still have two answers for that x squared term. So from our lesson that we learned in section 1.4 with complex numbers, we know that a negative inside the square root can be pulled out and made into an I, imaginary number I. And the square root, so I'm going to do plus or minus I, and then I can split up. Now that they're positive numbers, now that I took that negative number out, I can split up my square roots and do the top and the bottom separately. So I'm going to have plus or minus I times 5 over 3 square root of 25 and square root of 9. And I can rewrite this if I want. I'm just going to write it over here. X equals 5i over 3 and negative 5i over 3. It just looks a little bit nicer in this form, but it's the same answer as we had before. All right, then we have a second example here. Geez, I wish I had more room to work. You know what? I'm not going to do example 1, so I might need to scoot my work down into that space. So if I have x minus 2 quantity squared equals 6, what we're going to do here, if we think about trying to isolate that x, we can't move the negative 2 before dealing with the exponent because of our order of operations. So I have to deal with the exponent and get rid of it first before I can add 2 to both sides. I'm going to do that by square rooting both sides immediately. And remember, we have to do that plus or minus. When I square root the thing that's squared, it cancels out the squared. So now I have just x minus 2 on that side and a plus or minus square root of 6. Now I can add 2. It looks like I don't need extra room. I have a positive 2 plus or minus the square root of 6 as my two answers. You can split those into two answers if you want, or you can leave them together as I just did. All right, next page. Let me flip my notes here. So the next page, we're going to be looking at the quadratic formula. Set it over here. So again, I assume you've already done the quadratic formula, but just a little reminder, our quadratic formula, let me make this bigger here, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, I make my students sing it in class. So it helps you remember it. It's a cute little tune. We have this formula where we have ax squared plus bx plus c equals 0. So if our quadratic equation is in standard form, we can pick out our a's, b's, and c's. Just remember to pull those negatives with the numbers if they exist. So in this case, a is 2, b is -6, and c is a +1. All right, so let's look. We have x equals negative, and then b is -6. I'm going to show those negatives. Plus or minus the square root of -6 squared minus 4 times a is 2 times c is 1 all over 2a. All right, and then we can simplify. Negative times a negative is a positive, plus or minus. -6 times -6 is 36 minus 8 over 4. And I'm going to move up here. X equals 6 plus or minus the square root of 36 minus 8. Oh, it is an early morning, and I'm just going to make sure I don't mess that up. Use a calculator. 28 all over 4. We want to simplify that square root of 28. So the square root of 28 breaks into the square root of 7 times the square root of 4, which is the square root of 7 times 2. So I have 6 plus or minus 2 root 7 over 4. Now we have this, and this are all divisible by 2. So in order to simplify this equation, I do need to divide all those by 2. We don't want to affect the 7 because it's in the square root. It doesn't get to play with the others. So x equals 6. Oh, whoops. No, it doesn't. We're dividing by 2. 3 plus or minus the square root of 7 over 2 after I divide the 4 by 2. All right, so there's a nice example of quadratic formula. Now let's look at the second example here, which is a little different. We're going to see some imaginary numbers come up, so that's why I'm going to do this one too. All right, so jumping, I'm going to work a little faster here. X equals -b. Yes, I sing the song every time. b squared minus 4ac all over 2a. We have +2 plus or minus 4 minus 4 times 3 is 12 times 4 is 48 all over 6. If you notice, we're going to end up with a negative number in that square root. We have 2 plus or minus the square root of -44 all over 6. I need to pull out that I so that I don't have a negative inside the square root anymore. And then I want to simplify the square root of 44. I'm not going to show the work. If you need some help, let me know. It's going to be 2i root 11 all over 6. And then again, I want to look if this term, and this term are all divisible by something, we definitely want to simplify that. So I'm going to divide everything by 2. I'm going to have 1 plus or minus I root 11 all over 3. So we can still do the quadratic formula with imaginary numbers or real numbers. Either one is fine. Now, I did skip a problem. Go back and do that problem, please, and then check your work in the filled-in notes on our calendar. All right, the last part of our lesson here is using the discriminant. Actually, it's not the last part. There's one little part after this. So using the discriminant will help us determine the number and type of solutions for each problem without actually finding the solutions. So it's just kind of like a little shortcut if you just want to know what kind of solutions you have. The discriminant is this part of the quadratic formula. It's the b squared minus 4ac. So it's the piece inside the square root. And what that does, if that ends up being positive, so greater than 0, then you're going to have 2 real solutions. If b squared minus 4ac equals 0, you're going to have 1 real solution. It's actually going to be what we call a double root. And lastly, if b squared minus 4ac is less than 0, so if it's negative, then you're going to have 2 imaginary or complex solutions. And then there's one other really cool thing about the discriminant. if b squared minus 4ac is a perfect square. So if it's a perfect square number, like 1, 4, 9, 16, 25, 49, those sorts of things, then your equation is factorable. That is the bell at my school. I apologize for that. Okay, so let's finish this up. So finding the discriminant, I'm just going to do the b squared. So 4 squared minus 4 times a times c. And I have 16 plus, because a negative 4 times 3 times a negative 5 is going to end up being positive. So 12 times 5 is 60. I get 76, which is greater than 0. So I have 2 real solutions. And they wanted me to sketch a graph, what that looks like. And it's going to be a really rough graph. It's going to be something like this. So I'm going to have my equation crossing the x-axis in 2 real places. The next one, b squared minus 4ac. I get 36 minus 36, which equals 0. So I have 1 real solution. I'm abbreviating because I have to finish up here. What that looks like is when our parabola just touches our x-axis and bounces off, that would be our 1 real solution. And lastly, negative 8 squared minus 4 times a times c. I have 64 minus 12 times 7 is, and from here I get negative 20, which is less than 0. So I have 2 imaginary solutions. And what a sketch of that would look like, it would look something like this, where it doesn't cross the x-axis at all. All right, and that's it for today's lesson. Oh, no, it's not. Oh my gosh, I'm so sorry. There's one more piece here. Which method works best for each situation? So really quickly, what I always do is I always try to factor first. If I can't factor, then I use the quadratic formula. Factoring is just faster. You can also check to see if something is factorable by using the discriminant. Oops, discriminant. And I guess if only x squared and no x term, then use square roots. All right, and that's it. Have a nice day.